Hello, and welcome to this on-demand training about daylighting design and compliance for the B3 Guidelines. In this training video, we will cover Guideline I.5, Item C, which sets the requirements for daylight utilization and control in B3 projects. We will cover components of the guideline, including the B3 definition of regularly occupied spaces, the requirements for glare control, and the daylight utilization metrics. We'll close out with a quick overview of daylighting design strategies and best practices. The intent of Guideline I.5, which covers both electric light and daylighting, is as follows: to promote occupant comfort by providing adequate levels of natural and artificial light to maintain sufficient light levels for tasks being performed. Quality lighting can also support cognitive function, mental health, and social interaction while being aesthetically pleasing and complementing the design of the space. Guideline items I.5A and I.5B relate to electric lighting and are not addressed in this training. While some of the benefits described on the previous slide are applicable to all light sources, others are specific to daylight. For example, daylight is a key driver of our circadian rhythms. As the quality of the light changes throughout the day, it cues our bodies to release or suppress hormones that impact our alertness, sleep cycles, body temperature, digestion, and other physiological functions. Disruption of the body's circadian rhythm has been linked with obesity, diabetes, depression, and metabolic disorders. Since most people spend over 90% of our time indoors, providing indoor access to daylight can positively influence our productivity, alertness, and mood. Access to daylight also supports our innate desire to connect with nature. Daylight is often accompanied by views to the outdoors, but even when it is in the form of a skylight or solar tube, the change in light conditions throughout the day, the year, or even as a cloud passes over the sun helps us connect with our surroundings and mark the passage of time. Daylight can also offset energy used for electric lighting if properly controlled, though these savings have dropped quite a bit since the switch to LEDs, which use a lot less energy than their predecessors and don't put out much heat. Daylight is still a useful tool for resilience, enabling buildings to stay functional when the power goes out, and daylight can be used in concert with solar heat gain through glass to save heating energy if designed properly. Within the B3 guidelines, the daylighting requirement applies to all new construction and to major renovation projects that include replacement or construction of relevant systems and assemblies, such as new window openings. There is a compliance option designed for small buildings that will be covered later in the training session. The B3 Guidelines program, and especially the Indoor Environmental Quality Guidelines, are intended to focus on the spaces that occupants will spend the most time in. Because of this focus, we use the term regularly occupied space throughout the guidelines. We will now define this term and walk through an example of how to categorize spaces for compliance with this guideline. For the purposes of the B3 Guidelines, and specifically for Guideline I.5, lighting and daylighting, a regularly occupied space is defined as any space that is occupied by one or more persons for more than 1 hour during the days the building is in use. This includes spaces which may be irregularly occupied, but when occupied, a typical occupant would spend more than 1 continual hour in the space. The floor area of these regularly occupied spaces is defined as the regularly occupied floor area. Floor area is a component of the B3 daylighting worksheet that we will cover later in the slides. Some spaces are excluded from the definition of regularly occupied based on the lighting and daylighting requirements of specific programmatic uses. These exceptions include spaces with uses that only require minimal lighting and in which the primary activity intended for the space would be harmed by daylight, such as a theater. Additionally, spaces that do not meet the minimum occupancy outlined earlier during daylight hours are excluded. In other words, spaces that are regularly occupied, but where the occupancy happens overnight. Now we will walk through the process of identifying and listing regularly occupied spaces. This can be done with the room schedule list a floor plan, or other documentation available depending on the design phase. First, spaces that clearly do not meet the definition of regularly occupied can be excluded. Spaces such as hallways, inactive storage rooms, mechanical rooms, and bathrooms do not need to be listed or meet the daylight requirement. Similarly, spaces that clearly do meet the definition of regularly occupied spaces are identified. These spaces may be grouped into representative spaces to streamline the compliance process. Representative spaces can be used for rooms that are significantly similar in size, window-to-wall ratio, window-to-floor area ratio, and orientation. Here we've identified 3 groupings of similar spaces based on orientation, the depth of the room, and the window conditions. When listing regularly occupied spaces in the B3 daylighting worksheet, these rooms can be listed together, and daylight utilization can be modeled for one room with results assumed to apply to the other rooms listed for the representative space. This option is intended to reduce duplication of effort and save time for project teams while ensuring compliance with the daylighting guideline. The information listed here, including the room numbers and total square footage, is what will be entered into the B3 daylighting worksheet for these 3 representative spaces. Some spaces will be ambiguous as to whether they meet the definition of regularly occupied, such as a break room or reception area. Work with the client and the project team to determine the occupancy of these spaces to the best of your knowledge. In this example, the kitchenette does not have a seating area, and occupants are not expected to spend more than a few minutes here at a time, so it is excluded from the list of regularly occupied spaces. Now that we understand the intent, applicability, and definitions associated with Guideline I.5, Item C, we will now cover the specific requirements, starting with glare control. On all B3 projects, glare control is required for facades facing within 45 degrees of east, south, or west, since these are the directions that receive direct sunlight in Minnesota. Glare control devices are required to have manual controls or automatic controls with manual override. This enables building occupants to control the lighting conditions throughout the day and year, which has been identified in post-occupancy surveys of B3 projects to be an important element in ensuring occupant comfort and satisfaction. Glare control devices include interior window blinds, shades, and curtains, and exterior movable louvers, screens, and awnings. This image is an example of Venetian blinds installed in the window unit between 2 layers of glass to keep them clean, while also increasing effectiveness by placing them outside of the interior glass. An additional feature is dual operation that allows maximum daylight through the top of the window while controlling glare in the human viewing zone. Now we will cover the options for demonstrating daylight utilization, which addresses getting enough natural light into the space to support occupant comfort and well-being. The first option for demonstrating daylight utilization is with an analysis of the project's spatial daylight autonomy. This metric examines whether a space receives enough daylight to perform basic tasks without electric lighting, usually 30-foot candles, during standard operating hours, on an annual basis using hourly illuminance grids on the horizontal work plane. For compliance with the B3 guidelines, projects must achieve spatial daylight autonomy in at least 50% of their regularly occupied floor area. In other words, at least half of their regularly occupied floor area must achieve a minimum of 30-foot candles for at least half of the operating hours. This image shows the SDA results for 2 classrooms, both of which would be compliant with B3 guidelines. The B3 daylighting worksheet is required for submission for compliance with this guideline. The next few slides will show how to enter regularly occupied spaces and document results from daylight modeling simulations. First, spaces are listed with the square footage. As you recall, representative spaces may be used and should be listed with the total square footage represented and the room numbers included in the space. The spreadsheet will calculate the total area of regularly occupied spaces and the percentage each room makes up of the total to calculate the weighted average for compliance. This means that not every individual space must meet the 50% requirement, but that half of all the regularly occupied square footage does. As you complete daylight simulations in your preferred software, enter results into the spreadsheet. For some software, you may be simulating one space at a time, while in others, all spaces may be evaluated simultaneously. When modeling multiple areas at once, ensure that software outputs are reporting the room-by-room results so they can be recorded in the spreadsheet. Representative spaces can be modeled either altogether as a group or for a single representative room, since the same results would be expected for other spaces in the group. The spreadsheet will calculate the weighted average and display compliant when the SDA result is at or over 50%. As you can see, not all spaces are meeting the 50% requirement, but because other spaces are exceeding it, the group of rooms entered is compliant with this guideline requirement. The second option for demonstrating daylight utilization is daylight factor, which is the ratio of the light level inside the structure to the available light outside the structure under an overcast sky. For compliance with this guideline, projects must achieve a daylight factor of at least 1% in at least 50% of their regularly occupied area. The evaluation of compliance is based on the floor area achieving a daylight factor of 1 or more, not on the average daylight factor of each space. As with the first compliance option, spaces are listed with the square footage. Again, the spreadsheet will calculate the total area of regularly occupied spaces and the percentage each room makes up of that total to calculate the weighted average for compliance. This means that not every individual space must meet the 50% requirement, but that half of all the regularly occupied square footage does. Results from the daylight simulation may require specific analysis settings and/or manual calculation to determine the floor area with a daylight factor of 1% or higher. As with the spatial daylight autonomy option, results must be entered for each space or representative space rather than for the building as a whole. As simulations are performed, enter the percentage of floor area meeting the requirement. As with the spatial daylight autonomy option, the spreadsheet will calculate the weighted percent of area and display compliant when the result is at or over 50% of floor area. Again, as you can see, not all spaces are meeting the 50% requirement, but because other spaces are exceeding it, the group of rooms entered is compliant with this guideline requirement. As mentioned before, there is a compliance option for small buildings that is designed to reduce the effort required for smaller teams and budgets while maintaining the benefits of daylit spaces. Projects that include less than 20,000 gross square feet of conditioned space may demonstrate compliance with that guideline by ensuring that windows make up at least 35% of the exterior wall surface of regularly occupied spaces. This is known as a window-to-wall area ratio of 35%. Additionally, a minimum visible light transmittance of 0.65 is required for exterior glazing in regularly occupied spaces, which means that at least 65% of the visible light hitting the outside of the glass is able to get into the space. This is relatively simple to achieve for clear-looking glass, but may rule out tinted glass or some triple glazed window options. To calculate the window-to-wall area ratio, the total area of the windows in regularly occupied spaces is divided by the total exterior wall area of regularly occupied spaces. Exterior walls not adjacent to a regularly occupied space are not included in this calculation, and neither are regularly occupied spaces that are not adjacent to an exterior wall, though these must be recorded in the B3 daylighting worksheet. The examples shown here range from a 52% window-to-wall area ratio, number 1, to a 29% window-to-wall area ratio, number 4. Number 3 is showing 33%, close to meeting the B3 requirement. Number 2 and 1 do meet the B3 requirement. For the small buildings option, as with other compliance options, each regularly occupied space is identified and listed. The list of regularly occupied spaces should include any rooms or spaces that do not have exterior wall area. These spaces will not count against the calculation for compliance. The last tab of the B3 daylighting worksheet contains the small buildings option. Regularly occupied spaces and the window area for each must be entered. Window area includes the area of the entire window unit or units, including the frames. If you are using representative spaces, the total window area of all spaces represented should be entered here. Next, the exterior wall area and floor area must be entered. Exterior wall area refers to the interior finished face area of the exterior wall or walls in the space. Floor area refers to the interior finished floor area for that space. Again, inputs for representative spaces should include the total area for all spaces represented. Regularly occupied spaces with no exterior walls should be listed in the spreadsheet with their floor area identified and with zeros entered for the window and wall area inputs. These spaces will not be calculated, but are important for a more comprehensive understanding of the project's overall daylighting conditions. As values are entered, the spreadsheet will calculate the ratio result and indicate compliance when the window to wall requirement is met. As with other metrics, compliance is based on the total area, not on each individual space meeting the ratio required. The information needed for small buildings to calculate window to wall area ratios can typically be done directly within the building modeling software being used to develop architectural drawings, especially with the help of room schedules. However, daylight simulation for projects using the other two pathways often requires a plugin or separate tool. As of the recording of this training in July of 2023, the software options shown here have the ability to simulate spatial daylight autonomy and/or daylight factor. As mentioned, some software requires manual calculation or specific simulation settings to determine the floor area at or above a daylight factor of 1%. Refer to the built-in help menus in the software for additional information and directions. It's also important to note that each program takes a different approach to account for how light is reflected off of interior surfaces. Having primarily light-colored surfaces tends to contribute to higher light levels within a space, while dark surfaces tend to absorb light rather than reflecting it. Some programs allow users to enter surface reflectance inputs for specific materials or surfaces, while others use default assumptions. Projects with less reflective surfaces must ensure that they are using realistic values, which may narrow the set of tools available. For example, a space with an exposed concrete structure rather than a separate ceiling is unlikely to reflect a lot of light, so it would not be acceptable to use a tool with a default ceiling reflectance value of 70 or 80% to model this space. We've described how the B3 guidelines approach daylighting metrics, but what strategies can design teams use to optimize daylight levels? What needs to be considered during the early design phases, and what can be done if the project still isn't quite meeting the B3 thresholds as the design is getting finalized? There are some basic rules of thumb for daylight design. The first is to orient the building along the east-west axis to maximize the southern and northern exposure. As we see in this diagram of the National Renewable Energy Lab building, glazing on the south and north facades allows for daylight to fill the space by entering from both directions, without the hard-to-control low sun angles that we get on the east and west facades during morning and afternoon. In complement to the orientation of the building, narrow floor plates and high ceilings increase the floor area with access to daylight. When ideal orientation and narrow floor plates are not possible, overhead openings can provide daylight into deeply interior spaces. Finally, once the exterior openings have been optimized, using low partition heights and high reflectance materials can maximize the effectiveness of daylight. The lower diagram shows the order of importance for the reflectiveness of interior materials, starting with the ceiling, then the wall or walls opposite the windows, then the other walls, then the flooring, and finally furniture. The diagram to the right shows some ways to bounce light using interior elements like light shelves and partial or transparent interior walls. There is such a thing as too much daylight, especially when it results in extreme contrasts within a space, such as windows that get direct sunlight along one wall and limited light from other angles. Here we see some examples of exterior shading devices that can help reduce glare. In general, horizontal shading is more effective for high sun angles, such as on a south-facing window, while vertical shading can help reduce glare from low sun angles on east and west-facing windows. Solar angle calculations and side-by-side daylight simulations can help show the impact of different shading options. Exterior shading devices are also useful in preventing overheating from too much solar heat gain, since they block the heat from coming into the building. Since the sun is lower in the sky in the winter than the summer, solar angle studies can be used to design shading that lets the sun's light and heat inside in the winter while keeping out the heat in the summer. These diagrams show glare control strategies that can be used alone or in tandem with other solutions. You may recall that the B3 guidelines require glare control devices to be manually operated or automatically operated with manual overrides. With that in mind, glare management strategies may include automated or controlled elements that can be programmed to respond to light levels, time of day, time of year, or other factors. Glare management strategies and energy impacts can be tested with daylight and energy modeling, but will generally be easier for south-facing windows than on east and west-facing windows. Thank you for watching this informational session covering B3 Guideline I.5 Item C on daylighting. If you have additional questions or comments about the guideline or the submittal and compliance process, please contact the B3 Guidelines administrators at the email address shown on the screen. Resources for daylight design and daylight modeling software can be found in the description of this video and on the B3 Guideline page for I.5.